Hey guys, welcome to another video. In this video I'm going to be going through the Edexcel GCSE Maths exam paper 3. This was a calculator paper and this was set on the 13th of June 2017. Before I start, I just want to apologise for the mic. It might sound a little bit weird. My proper microphone broke, so I'm just using the built-in microphone on my laptop, and I think it sounds a little bit echoey, a little bit weird, but rather than wait for the new microphone to arrive, I thought I'd record this video and get it up, and rather than kind of delay that. So I apologize for how the microphone sounds. Second thing is I'm going to break this paper up. I'm going to go through the whole paper, and in this video I'm going to go through questions 1 to 10. In the next video I'm going to go through questions 11 to 20 just to break it up a little bit. Let me know if you'd prefer it all in one video or if you like it broken up like that. Okay, so let's get started. Question 1 says, this is a Venn diagram question, and it says, the universal set includes all of the odd numbers less than 30. Set A is the numbers 3, 9, 15, 21, 27, and set B is the numbers 5, 15, and 25. And part A says, complete the Venn diagram to represent this information. So here we've got the universal set symbol, and we can go ahead and label these circles, A and B. And then we need to decide what goes into these circles. So first we need to identify, is there any intersection or common numbers? And we can see that 15 is a common number between those, and that's going to go right in the middle here. And there's no others, so all of these, the rest of the numbers there are going to fit into A, and the rest of the numbers in B are going to go in here, so we've got 5 and 25 there. And we're not quite finished yet because we need the rest of the numbers in this universal set outside of those two sets, and that's the rest of the odd numbers. So that's going to be, you need to think about it a little bit, which ones I need to write down here. So it's going to be 1, 7, 11, 13, 17, 19, 23, and 29. And that should include all of the odd numbers less than 30. The second part of this question says, a number is chosen at random from the universal set E. What is the probability that the number is in the set A union B? Symbol means union. And the other one you might have seen is the cap looking one, and that means A intersect B. So union is all of the numbers in A and B, and the intersect is only the numbers in this intersection. So we want all of these numbers and the probability that we'd choose one of those. So all of the odd numbers less than 30, well that's 15, because that's half of the numbers less than 30. And the numbers in these two sets, we can count them, 1, 2, 3, 4, 5, 6, 7. So the probability of picking a number from A union B will be 7 out of 15. And that's question 1. Question 2 says, solve these simultaneous equations. And they made it, well, I won't say easy, but they made it a little bit less difficult than it could have been because the coefficients for x here are already equal. We don't have to multiply any of these equations to make any of the coefficients equal. So remember these rules: same sign subtract and add different signs. Add different signs. Hopefully you've seen these rules in relation to simultaneous equations. So what this is saying is if the coefficients that are equal have the same signs, in other words if they're both positive like these two 3x's, we subtract them. We subtract the equations. So now we can subtract each of the terms in these equations, and we can come up with our solution. So 3x take 3x, well that's 0, and that's the reason we're doing this, to eliminate one of the variables. And then plus y minus 4y, that's going to be plus 5y. And then I've got minus 4 minus 6, that's going to be minus 10. And if we solve that equation, we'll get y equals minus 2. And then we need to do the second part of this. So we've got the value for y, and now we need to find the value for x. So we can substitute that into one of these equations. So if we substitute it into the first one, we get 3x minus 2 equals minus 4, and then we can go ahead and solve this to find the value for x. And if we add that 2 to this side, that will be 3x equals minus 2, and then x equals minus 2 on 3. And now we've got a value for y and a value for x, and we're done. Question 3 gives us a table, and it says this table shows some information about the dress sizes of 25 women. And it says find the median dress size. So always try to remember the mean, median, and mode and what they mean. So the median is the middle value of a list of numbers. And if we're looking at this table, we've got 2 women with a dress size of 8, 9 women with a dress size of 10, 8 women with a dress size of 12, and 6 women with a dress size of 14. And what these tables do, remember, is they summarize a list of numbers. So we could write all of these dress sizes out in a big list, and we'd have 2 8s, 9 10s, and 8 12s, and 6 14s, all in a big list. But what this table does is it condenses that information to make it easier to process. So when we're asking for the middle number, maybe it's easier to think of these numbers in a list, and we want the middle one. So if we count all of these up first, well, if we add all of these up, 2 plus 9 plus 8 plus 6, that'll be 25 women that were surveyed, and we want the middle value. So remember to find the median position or the median value. I usually say median position, but you might call that something else. We do n plus 1 divided by 2. That gives us the middle of the list of numbers. So we'll do 25 plus 1 divided by 2, that would be 13. So we want the 13th value in this list of numbers. And if we count up, starting at the start of the table, if we count up from here. So we go 2 women and then plus 9, so that's 11. So the 13th woman, or the 13th value, will be in here, in this row here of the dress size of 12. So the median position is the 13th value, and that the median dress size is going to be 12. I know that can sometimes be a confusing concept, but hopefully that made sense. Okay, the second part of this question says 3 out of 25 women have a shoe size of 7. Zoe says that if you choose at random one of the 25 women, the probability that she has either a shoe size of 7 or a dress size of 14 is 9 out of 25, because 3 over 25 plus 6 over 25 equals 9 over 25. Is Zoe correct? You must give a reason for your answer. So let's just check our numbers are correct. So if 3 women have a dress size of 7, that would be 3 out of 25. That probability is correct. And 6 women have a dress size of 14, so that probability is correct. And her reasoning would be accurate if it wasn't for the fact that there's one thing stopping this from being right. And what that is if a woman has a shoe size of 7, she can also have a dress size of 14. So they're not mutually exclusive. So we don't know that these probabilities are mutually exclusive, so we can't add them together and get that final probability. So we can say, so she's not correct. No, the probabilities are not mutually exclusive. Probabilities are not. Mutually exclusive. What that means is that we don't know if one of these women with a dress size of 14 didn't also have a shoe size of 7. And that's all you need to say to answer that question. Question 4 is involving ratios and percentages. And this is similar to a question in the second paper. in which you need to use your knowledge of fractions, percentages, and ratios in order to get to the final answer. So Daniel bakes 420 cakes. He bakes only vanilla cakes, banana cakes, lemon cakes, and chocolate cakes. 2 of the 7 cakes are vanilla cakes, 35% of the cakes are banana cakes. The ratio of the number of lemon cakes to the number of chocolate cakes is 4 to 5, and it's asking us to work out the number of lemon cakes Daniel bakes. So this sentence is telling us how many vanilla cakes there are. This one's telling us how many banana cakes there are. And then we need to use this ratio to get to the final answer. So we know how to find a fraction of an amount. We multiply that fraction by the total, and that will give us 120 vanilla cakes. We also know how to find a percentage of an amount. Usually I multiply it by the multiplier. You might have your own method, but with a calculator, generally this is the quickest way. 0.35 times 420, and that gives us 147 banana cakes. Now, we know the ratio of lemon cakes to chocolate cakes is 4 to 5. We need to know how many lemon cakes and chocolate cakes there are. So what we could do is we could add these together, and that gives us 267 vanilla and banana cakes. Therefore, the remainder are lemon and chocolate cakes. So if we subtract that number from 420, we get 153. And then we need to work with that number in this ratio. So 9 parts is the total. So 153 is 9 parts in total. So 1 part will be 153 divided by 9, and that will be 17. So 1 part in this ratio is worth 17 cakes. So therefore, if we've got 4 parts of that, we can do 4 times 17, and that will give us 68. And we are looking for the number of lemon cakes, which will be the four parts there. So we've got our answer there. So the number of lemon cakes is 68. Oops. And you could always check if you want, and I'd encourage this to find the number of chocolate cakes as well and make sure they all add up. But that's that question finished. On to question 5. Question 5 says, in the diagram AB, BC and CD are 3 sides of a regular polygon P. So there are these lines here, and there's some shape in there inside there. So these, you can imagine these sides continuing. And it asks us, show that polygon P is a hexagon. You must show your working. And there's some more information in the picture. It says this is a regular 12-sided polygon, in other words a dodecagon, and these are squares. Generally when it shows you a picture like this and asks you to prove that one shape is a hexagon or one shape is some regular shape, you need to use the formulas for interior and exterior angles of polygons. So generally the formula for finding the total of the interior shapes goes like this: n minus 2 times 180, and that will give you the total of the angles in a polygon. And what we can do is, and then you can divide that by the number of sides, and that gives you one angle inside that polygon. So using this, we need to prove that this is a hexagon. Well, the first thing we could do is find what one angle of a hexagon is, and because it's asking us to show, you might know that what the interior angle of a hexagon needs to be, but you need to prove it, you need to show it in your working out. So we know that a hexagon has 6 sides. So one angle of a hexagon is going to be 6 minus 2 times 180 divided by the number of sides 6. And if you work all of that out, you get 120. So that's the interior angle of a hexagon. Interior angle of hexagon. And you might want to set your working out a little bit neater than this. I'm kind of rushing because I'm trying to do it in a video, but if I was doing this in an exam, I might do it a little bit neater. So that's what one of these angles needs to be. We need to show that that would be 120. So next we could find what one angle of a dodecagon is using 12 in this formula. So let's plug 12 into there. And oops, that should be 12 down the bottom. And if you work that formula out, you get an answer of 150 degrees. So this angle in here is 150. Obviously you should know, I think you don't really need to prove that the angle in a square is 90. So we've shown that this angle is 150. We know that the angle of a square is 90, and then we can take those away. So 360 minus 90 minus 150. If you do that sum, you get 120. So that angle there must be 120 using these two facts. Also, we know the angle of the interior angle of a hexagon is 120. Therefore, we can say that polygon P must be a hexagon. Polygon P must be a hexagon. By the way, I might do a video on this formula just to explain where the derivation of it, how it works, but I'm assuming most of you kind of understand or have seen that before. Okay, moving on. Question 6 says the density of apple juice is 1.05 grams per centimeter cubed, the density of fruit syrup is 1.4 grams per centimeter cubed, and the density of carbonated water is 0.99 grams per centimeter cubed. 25 centimeters cubed of apple juice are mixed with 15 centimeters cubed of fruit syrup and 280 centimeters cubed of carbonated water to make a drink with a volume of 320 centimeters cubed. Work out the density of the drink, give your answer correct to 2 decimal places. Okay. So we've got a drink with a volume of 320 centimeters cubed made up of these 3 mixtures. So for a density, we need the weight and we need the volume. So we're given the volume and we need to work out the weight using these facts here. So basically you just need to do some calculations multiplying these values. So the weight of the density of the apple juice is 1.05 multiplied by how much apple juice is in the mixture. That will give us 26.25 grams. Then we've got 15 centimeters cubed of fruit syrup, and that's at a weight of 1.4 grams per centimeters cubed. So 1.4 times 15. And then we've got 280 centimeters cubed of carbonated water at 0.99 grams per centimeters cubed. So then we need to do 0.99 times 280, and that will give us 277.2 grams. Then we can add all of those up. If you add all of those up, you get 324.45. And we know the volume is 320, so we can say the weight divided by the volume, or grams per centimeters cubed, gives us, if you put that into a calculator, it gets 1.013906, and they keep going, and it says to 2 decimal places, so this is going to 1.01 grams per centimeters cubed. Pretty straightforward question, I think. Question 7 says ABC is a right angle triangle, and they give you this diagram with an angle and one side, and it says calculate the length of AB. Give your answer correct to 3 significant figures. Usually when you see an angle and a right angle triangle and one length, you should start thinking trigonometry and the trigonometric ratios, and hopefully you have this memorized. So katoa. And what this is saying is when you're using sine, we have the opposite and the hypotenuse, and when we're using cosine, we use the adjacent and the hypotenuse, and when we use tan, we use the opposite and the adjacent. So from this angle, we've got the hypotenuse, and we're looking for the opposite side. So the opposite and the hypotenuse will be using sine theta. We'll be using the sine operation. So we can say that sine theta equals opposite over hypotenuse. And here theta is 23, so sine of 23 equals, now we don't know AB, so we need to put that in as a variable. And we know that the hypotenuse is 15. And if we rearrange this, we get AB equals, well, take that over to the other side, so we need to multiply sine 23 by 15. And if you put that into your calculator, you get 5.860969, and it's saying to 3 significant figures, so that's going to be to the third significant figure here, so 5.86, and always check the unit, so that's centimeters, so this is going to be 5.86 centimeters, and that's your final answer for that question. A pretty straightforward trigonometry question. Question 8 says, a square with a side of x centimeters is inside a circle. Each vertex of the square is on the circumference of the circle. The area of the circle is 49 centimeters squared. Work out the value of x and give your answer correct to 3 significant figures. Okay, so there's a few pieces of information here we need to extract. So the first one is the square is inside a circle. I'm going to firstly do a really rough sketch. So excuse me if this is a little bit messy. Okay, so we've got something like this. We've got a circle and a square. And each vertex of the square is on the circumference of the circle. So you can imagine they're just touching there. And the area of the circle is 49 centimeters squared. And that's all the information they give us. We are looking for one side of this square x. Well, we know that using the formula for the area of a circle, which is area equals pi r squared, we can use that to find the radius of the circle. So we can rearrange this formula to say that 49 equals pi r squared, therefore r is going to be, well, divide by pi and then take the square root, so that would be 7 on the square root of pi. And you can either work out the decimal answer for that or just leave it as 7 over square root pi. I'm just going to leave it like that for now. So we have the radius, basically this side in here, and also this one. And once you've got to that step, there is a few different options, and probably the easiest way to approach this, I think, is to use this right angle triangle and use Pythagoras' theorem to find the hypotenuse, because I'll sketch this triangle out again. I've taken that triangle from this circle and brought it out here. So you can see that this is the right angle triangle. These are the radiuses. So this is 7 on square root pi. And this is also a radius, 7 on square root pi. You can see this is a right angle triangle, and we're looking for this side here. Hopefully you can see that I've just taken that triangle and drawn it here. So now we can use Pythagoras' theorem to find the hypotenuse. So Pythagoras' theorem says that the a squared plus b squared equals c squared, so 7 on square root pi squared plus the same thing, 7 on square root pi squared equals x squared. Now, so if you're working this part out, you could square those and square the 7s and square the square root of pi. So on this side, you end up with actually 98 on pi. And then if you take the square root of that, you'll get your answer for x. So put that into a calculator and you get 5.58519, etc. And then the question says, give your answer to 3 significant figures, so that's going to 5.59 centimeters. Now you might end up with a slightly different answer depending on how you've done your working out here. So if you've taken a decimal, if you've rounded that to a decimal here, and you've put a slightly different answer into this equation, you might get something a little bit different to this. You might get 5.58 or even 5.6. And the markers know that, so they're given a range from, I think, 5.57 to 5.6, and they accept anything in that range. But I'd say this, because I haven't rounded anything, this would be the most accurate answer. Okay. Question 9 says, the box plot shows information about the distribution of the amounts of money spent by some male students on their holidays. So we can have a look at this graph. This is representing the male students and the money spent. So we've got values from 0 to 1000. And looking at this box plot, remember the whiskers on a box plot represent the minimum and the maximum. So the minimum amount spent was, have a look at the graph lines carefully and you'll notice they represent 20s. So this represents 20 and this represents 750. So they're the minimum, maximum, and then the quartiles here represent 25, 50% and 75%. And so the lower quartile was 150, the median was 250, and the upper quartile was 330. And part A says, work out the interquartile range for the amounts of money spent for these male students. Okay, so the interquartile range, remember, is the difference between the lower quartile and the upper quartile. So the lower quartile, as I said, was 150, and the upper quartile is 330. So we can say the interquartile range is the difference between those. 330 take 150, 180. The second part of this question says, the table below shows information about the distribution of the amounts of money spent by some female students on their holidays. Okay, and so here we've got the money spent, the minimum 60, maximum 650, and the various values in there. And that's asking us to, on part B says, on the grid above, draw a box plot for the information in the table. Okay, that should be easy enough. They've given us all of the values. We don't have to work out any of them. And so let's draw it here. So we're given the minimum was 60. Okay, the maximum 650 in there somewhere. The median was 300. The lower quartile 180. And the upper quartile 350. Okay, that looks good. And then we need to join the box up and connect the whiskers, and that should be a pretty good box plot for the female students. Make sure to label it as well, just as they do in the question. Okay, so just double checking, yep, got everything. So that's part B. And then part C says, Chris says the box plots show that the female students spent more money than the male students. Is Chris correct? Give a reason for your answer. So we need to go back and look at those box plots. And he said that the female students spent more than the male students. Really, there's only one value you really care about when you're comparing two lots of data, and that's an average. So the only average from a box plot you can get is the median. And this is saying the median for the female students is higher than the male students. So we kind of ignore the minimums and maximums in the interquartiles. We could use the interquartile range as a measure of spread, but not really to compare how much each spent. So we use the average there, the median. We say the median for the females is higher, so therefore, yes, they did spend more. But really, they want you to compare the medians there. So we can say yes, as the median is higher, as the median for the female students is higher. And that's what we really need to say for part C. Question 10, and this will be the last question I do in this video. And then I'll do questions 11 to 20 in the next video. So question 10 says, Niobe invests £6,000 for 5 years. The investment gets compound interest of X% per annum. At the end of 5 years, the investment is worth 8,029.35. Work out the value of X. Okay, so if you've done compound interest problems before, you might not have seen this working out the percentage. There's always, in these compound interest formulas, they always ask you to find out the number of years, the percentage, or the amount at the end. So you need to be able to answer each of those confidently. So there's a couple of ways you could do this, as always. Firstly, I'll start off by writing down the formula. So the amount at the end is equal to the principal times 1 plus the rate to the power of the number of years. Or I think usually we actually use n for that, don't we? So the principal you start with times 1 plus the rate to the power of the years. So if we fill in those values in that formula, we could see how we could start working this out. So the amount at the end we know is 8,029.35, and the principal we know, 6,000. The rate is the thing we don't know, and we know the amount of years. So you could either you can do a trial and error method where you can say 1.05 might be a good place to start and work out the multiplier. And if that doesn't work, you could do 1.06 and work out the multiplier. Or you could rearrange this formula to find R. So I'm going to do it that way, but there's nothing at all wrong with doing it this way either. So if we rearrange that formula, we get 1 plus R to the power of 5 equals 8,029.35 over 6,000. And then we can do the fifth root of what we get here. And if you put that into a calculator, and then obviously you have to subtract 1 at the end. If you work all of that out, you get R equaling 6%, 0.06, which is 6%. Well, they've called it X, so we should call it X in our answer. So X equals 6%. And also, if you did it this way, you get to 1.06 to the power of 5. You get that multiplier, multiply 6,000 by that number, and it comes out to 8,029.35 something. It's not perfectly, but if you round it off, you get that. So you'd get the same answer if you did it this way as well. Okay, sorry if I was sounded a bit weird on that microphone in this video. It's off-putting for me as well, because I don't have my usual setup. So I apologise for that. I hope this has still been helpful, and if you want to see the rest of the paper, watch part 2 to get my working out for the rest of the paper as well. Thanks for watching, and I'll see you in the next one. Bye.